Welcome to the transformations. What I want to do today is show you how to identify transformations when given a function. Now, there's a lot of different ways I could show you how to identify which transformation is which and why it is that it works. But for this video, I just really want to focus on the different types of transformations and how, when we can look at it at a function point of view, how we can quickly determine what that transformation is and then quickly write it down and identify it. So, what we're going to do is we're just going to kind of talk about, where a number or a negative sign is going to be, how that's going to affect our function. So remember, we're just going to have a function. We could equal, really any multiple types of functions. If you can see, labeled in the green, I have a lot of different functions that we're going to pick from. Obviously, this isn't even close to the different types of functions you will encounter, but it's kind of covers a wide base of a power, a root, absolute value, to help you out kind of get started with them. So when we're talking about transformations, a lot of times when we learn about graphs, and I think it's important when you are learning how to graph a certain type of function, it's really important for you to see what the parent function is. Because the parent function is like the identity part of that graph where there have been no transformations. That means whatever input you plug into your function, that output just goes direct with that function. There's nothing else that's affecting it. There's no other outside factors that's transforming, shifting it right, shifting it left, shifting it up, down, reflecting it, like that. So it's really important for you to understand the parent graph. And in another video, I'll show you how to draw parent graphs and then how to do the transformations, with the graph. But for today, I just want to look at the function. So let's say we're having a function, and we could be using any function f of x. I could have plugged in a function, let's say x squared, but I really just kind of want to let you know that we're going to have a number c, and c is going to represent any real number. And I want to kind of write down the little tips, and I hope that you write them down as well, to kind of remember, no matter where c is, it's going to affect our function in different manners. So therefore, if I have my c in front of my function, we'll show you a couple examples of what that looks like. How is that going to affect my function? Well, when you have c in front, what it calls is, that's going to work as like a multiple. I'm sorry, not a multiple. That's going to work as either expanding or shrinking your function. Now, it determines on what is the size of your c, all right? Because sometimes the size of c, if it's is going to expand the function, and sometimes it's going to kind of shrink it, or like we say, compress it. So for here, I'm just going to say stretch or compress. And that's really what when you have a number in front of there, that is really going to stretch and compress. Now, when I have an add a c, now remember, if I added a negative c, I could say f of x minus c, right? Well, so I'm just going to use the positive version of this, but the adding c, anytime I'm going to be adding c, this is going to be shifting my graph up or down. So, pretty much what I mean by there, if I have like x squared, and I say x squared has not changed, but then plus 1, that means I'm going to take the whole x squared graph and then move it up 1. If I have a negative value in front of my function, that means it's going to be a negative f of x. So, I have a couple examples in here, but if I have my negative version of my function, what that's going to do is that's going to reflect my whole function, sorry, I can't speak now, over the x-axis. If I'm going to have a negative version of my x inside of my function, what that's going to do is that's going to tell me I'm going to reflect the y-axis. And like I said, we'll go through examples of all these through my problems. Now the last one, in most standard forms of your graph, you're going to see this as like your x minus h, and it's going to be always minus. And that's a very important thing for you to understand is it's usually the opposite inside of a function. So what I'm talking about this says f of x plus c, meaning if c is positive, we go up. And if c would have been negative, we would shift down. Now, usually inside of a function, that's actually the opposite. So for most standard formulas, you'll see that it'll be x minus h. What that means is, if c was positive, you're actually going to take the opposite of it, and you go the other direction that you would think. So, but regardless, we'll talk about that when I get to them. X plus c, that's going to tell us my graph is going to shift left or right. Okay, so far what I have is 5 transformations up here, and what I'm going to do is I'm just going to go through some problems, and then I'm going to give you some problems that I'd like you to solve to see how you do, and we'll just kind of talk about a transformation and determine how do I know what the transform was for each problem. Alright, let's look at the first one. So here I have my function is f of x equals x squared. So my function is x squared. Alright, now I need to look at anything that's changing my x squared. What is it doing? So I have f of x equals x squared, and then it says x squared minus 9. So therefore, I'm going to apply this rule, f of x plus c. What I've done is, I've changed my function by adding a negative 9. So one thing to notice is how do you know if it's shifting up or down? Well, when you add a negative number, if that number is negative, you're going to shift down. So I'm going to write shift 9 units down. Okay, so I'm going to graph my regular function like it's a paragraph, and then I'm going to shift it 9 units down. Now here, again, I look at my function. I have f of x equals the square root of x. Now my transformation is the square root of x minus 7. So the transformation of inside of a function, you know what, maybe even would have been better just to write it as x minus h or x minus c to let you guys know that. But when you have your x minus your 7, what that's going to do is, that really tells me x minus a positive 7. So I'm actually going to shift this, because I said it was x minus a positive 7. I'm going to shift my graph 7 units to the right. Because remember, whenever you have a function, or you have a number inside of your function, that's going to tell us to shift to left or right. So I'll just let you know it now. All my functions, you have your x plus c. Well, I think it's easier for me to describe it x minus c, that's why I changed it. So whenever it's x minus c, if your c, it's x minus whatever the value of c is. Well, my value of my c here is positive. This gets really confusing for a lot of students. Let me put it to you this way, and let me see if I have another problem here. Well, okay. I don't know if I want to explain it all this way, but you could say this is x minus a positive 7, which still is x minus 7. But the reason why I just show you that can be a positive, x minus a positive number, is to let you know that you're going to be shifting 7 units to the right. And I'll explain this in my next step. The other way you could always look at it, a lot of version that a lot of teachers like to say is, just remember that when it's shifting up and down, if it's positive, you go up, negative, you go down. When it's inside the function, if it's negative, you go to the opposite, you go to the right, and if it's positive, you go to the left. You can always just think of it that way too. So here, I'm going to have, I'm going to shift 7 units to the right. For the next problem, again, what I see is x minus c, right? Well, c then has to be a negative number. And that's what I was trying to show you in this previous problem. It's x minus c. I could write it as x minus a negative 3. Either way, this is going to tell me, again, I have a c inside of my function, right? So here my function is f of x equals the absolute value of x. So what my transformation is now inside of this function plus 3, outside of the function minus 5. So when it's inside of the function, that tells me to shift left or right. So x plus 3 or x minus a negative 3 is going to tell me to shift 3 units left and 5 units down. Okay? So I hope I really didn't confuse you too much with the double negative and here the negative positive. Just kind of remember, if it's positive inside the function, then you're going to shift to your left. And if it's negative, you shift to your right. If you understand that, that's awesome. It'll help you kind of get a general understanding overall. Here, I have a negative sign. Now my function is f of x equals x squared. The negative sign is outside of my function, therefore I'm going to reflect my x-axis. I have a x plus 3, which is inside of my function, so I'll shift 3 units left. And I have a plus 1. That means I'm going to shift 1 unit up. Okay? Over here, I have a negative square root of x plus 1. Again, I'm going to be reflecting my x-axis. Here, it's going to tell me plus 1. That means I'm going to shift 1 unit left. And I'm going to shift 9 units down. All right, lastly, here I just have a number in front. I'm not adding or subtracting anything, so I'm not going to be shifting to left or right. I don't have a negative sign, so I'm not going to be reflecting it at all. However, you could say, well, how is it going to stretch and compress? And I really don't, every kind of function is going to be kind of different on how it describes it. But, so I don't want to kind of get too much in here, but just notice that that 3 is going to stretch or compress this function. And I'd really like to take a different time of video to show you how it alters when it's 3 or 1/3, the different types of functions. But for right now, you can just know that it's going to stretch and compress at a magnitude of 3. So now what I'd like to do is write up some functions up there for you guys to do and see if you can figure out what the transformations are. God. Okay, if you could please write down these problems, what I'd like you to do is go ahead and see if you can solve them, solve the transformation on your own, and then I'll come up and show you the answers. Okay, that's enough time here for you. So hopefully you had an opportunity. If not, go ahead and pause the video and try to do them on your own. Number 1, it's a little bit difficult because you're like, wait a minute, we didn't ever have a number, added in front or subtracted in front. What's going on? Well, all I did was I just rewrote the equation for this one. So to solve this one, you might want to rewrite it in terms the way that you're used to. Therefore, now you can see your function x squared. And you notice I'm adding a 12. That's going to tell me I'm going to shift up. And I'm going to have a negative function, so that's going to mean I'm going to reflect the x-axis. So let me write it. All right. For next one, number 2. I'm sorry, I forgot to mention for 1, 2, and 3, those are all using the parent function x squared. So for number 2, again, I have this negative in front of my function. That's going to tell me to reflect the x-axis. The plus 5 tells me I'm going to shift, here we go, left or right, and since it's plus 5, I'm going to shift 5 left. The plus 2 tells me I'm going to shift 2 up. Over here, I have a x minus 8. That's going to tell me now I'm going to shift 8 units to the right. And lastly, I have a negative 1/3 square root of negative x. So I have negative sign outside my function, and I have a negative sign inside my function. So the negative outside is going to reflect the x. The negative inside is reflect the y. And the 1/3 is going to be in terms of compressing or stretching my function. And like I said in the freeze problem, I'd like to kind of show you in a different video how that is actually going to affect your graph. So ladies and gentlemen, that's how we use transformations to determine a function, how it's been translated, transformed really with a reflection, a shift, and up and down. So I hope this helped you out. I hope you guys got some practice and you're all good right. If not, check out my other videos or shoot me a message and let me know how I can help you. Thanks.